So now we have 4 signals, x1n, x2n, x3n, and x4n. We have 4 signals. You have to find the question mark is like it can be 1, 2, or 0, or -3, -2, or -1. So what combination of x1, x2, x3, and x4 is going to give you the output that you see here? The output is the signal that you see here. You input AX1, you're going to get an output of Y1N. If you input B, the output going to be B, Y1N. If we input C, X3N, the output is going to be C, Y1N. A, B, C, D, let's say we put a DX4N, the output is going to be D, Y1, Y1XN. Something like that, okay? This is, remember last time when we had a linear system, we have to test for additivity, and we have to also test for the superposition. If you sum the individual input AX1N plus AX2N plus plus BX2N plus C X3N plus D X4N. For a linear system, this should give you A Y1N plus B Y2N and C Y3N plus D Y4N. Okay. Now applying this to the previous problem, we need to find A. For your problem, we need to find A, B, C, and D. Okay, so let's start. Okay, if you look, when n equal to 0, you look everywhere when n equal to 0, there's no signal, right? There's no signal. No signal at n equal to 0, no signal, no signal, no signal. And also at the output, there's no signal. So therefore, we don't have to worry about evaluating that point. Now we go to the next one. When n equals to 1, you have signals. When n equals to 1, there's a signal here. There's no signal here, but there's a signal here, and no signal here, but one of them has a signal. So we have at least 2 having a signal. So we have to consider that. So let's write the equation for x1. AX1 AX1 n plus BX1 BX2 n So we are doing it at x1, right? So let's put n is 1. 1, n is 1, plus c x3, n is 1, plus b x4, 1.
Not D.
That's, beg your pardon?
Not
Yeah, D.
donkey.
Okay, yes, a donkey. D. And that's going to be equal to 0 because at the output, and you see there is a 0 signal there. So at the output is a 0 signal. So you're going to set that equal to 0 when n equals to 1. Okay, that's equation number 1. So you're going to write the other equations. Like for example, if now let's write the equation, the next equation. I'm going to do that. It's x1, 2. At 2 also you have non-zero signals. So therefore we're going to write an equation for that. So it's going to be ax12 plus b x22 plus c x2 c x2 sorry x32 plus d. Okay, it's really worth it to know this problem, you know. Really worth it to know this problem because you're going to see something like this in the final exam. Okay. D x4 2 is equals to, now we come here and look at 2, so we have a signal here with an amplitude 3. Therefore, you set it equal to 3. Then you go on and write the next equation for ax1 3 plus bx2 3 plus cx3 3 plus dx4 3. And at the output, there's no signal at 3, there's 0 signal. So therefore, I put a 0. Then you do one more. ax14 plus bx24 plus c x3 4 plus d x4 4. And that's going to be equals to, become and see, and then you can see it's a -1 here. The amplitude is -1. The signal is a negative signal with an amplitude of 1. Okay, now we need to plug in numbers. So we go and look here. Like if you look x1, for example, when you look at x1, just show you one of them. In x1, the amplitude is 3, and the amplitude here is 0. The amplitude here is 0. The amplitude here is 1. The amplitude here is also 1. So you need to plug in these values for the xn's. Therefore, this is going to be 1 here, and that's going to be 0, And that's the next one is going to be 1, 1, 1. Okay, therefore your equation here is going to be A ACD equal to 0. A plus C plus D is equal to 0. That's equation number 1. If you do a similar deal, then you get next one. You're going to get a 2A because at x1, the x1, 2, x1, 2. Come and look at x1 at 2. The amplitude is 2. A plus 3B. I mean, there may be some algebraic error. You know, if you see anything like that, please let me know.
So for the first equation A, the x1n is equal to 3, right?
x1n, first one.
Yes, sir, the first equation.
x1n. x1n, yeah, is 3. Yes, that's a mistake here. x1n is 3. Okay, let's go and change that to 3. Thank you. 3. Therefore, this is 3A. Who was that? Who identified that?
It's me, sir. Call Jeff.
Oh, Jeff, oh, good job. Okay, Jeff. Yes, Jeff. You find out that is that's a mistake there. Okay, thank you. So the next one, if you guys look again, we are having at 2. Now you just focus on position 2. You just focus on position 2. Is going to be 2, 0, 2, 0, 0, 2, right? x2, 2, x1, 2 is 2. Okay, 2. And the next one, x2, 2, x2, 2 is 0. x2, 2 is 0. So let's do this first. 2, 0, x3, 2 is also 0. So also 0. x4, 2. x4, 2 is how many? 2. x4, 2 is 2. It's equals to 3 because the output is 3 at position 2. So therefore, I can write an equation for this. So this is going to be 2A and then plus 2D is equals to 3. So this is another equation. Is this okay? So next, look at x1, 3. x1, 3 is 1. x2, 3 is 3. 1, 3. 1, 3. x3, 3. x3, 3 is 0. x4, 3 is 3. 3. So it's going to be then A plus 3B plus 3D is equals to 0. So next one is x for 1. X for 1 is 1. X for 2 is 2. X for 3 is 3. So it's 1, 2, 3. 1, 2, 3, 0. Am I right? Somebody's burping.
Can you please check equation number 3, sir?
Number 3. Okay.
Yeah, equation 3.
A.
Sorry, equation number 4. Equation number 4. The last one, the x14.
X14. Okay, X14 is how much? X14 is 0.
Yes.
It's 0. How come then I saw it as 1?
Sir, only saw the graph of x for n.
X13. Okay, let's look at it again. Okay, X13. Hold on a second. X13 is, see, I'm looking, okay, hold on a second. X14. This is X1, and I'm looking at this one right here. Okay. So it's 0, right? It's 0,
Yes.
right, guys?
Yes.
0204 is it?
0.
0, 2, 0, 0, 2, 0.
0. Okay, okay, X24 is X24 is 2, right?
0, 2, 0, 0, 0, 2, 0, 0, sir.
Oh, sorry, 00.
0, 0. Okay, X34 also 0. 1, 2, 3, 4. Also 0. 0, 0. That's a beauty. So 2b is equals to -1. Okay, b is 3 minus 1/2 plus 3d. So 3 over 2. So d is 1/2, right? Agree? So once you have this, you have b and d. So from 2, from 2, 2a plus 2d is equal to 3. So 2 times 1/2, 2a. 2a plus 2d, 2a plus 2, 1/2 is 3. So this is going to be 2a. Is going to be 3 minus 1 is equals to 2. So a is equals to 1. B is equals to 1/2. D is equals to 1/2. A is equal to 1. Then what's going to be the last one? The last one, one more, we need to find C. So from 1, is a 3a plus C plus D. 3a plus C plus D is equals to 0. You plug in all those values. So you get C is equals to minus 3A minus D. If you don't like to do that, then you can just simply plug in here, plug it in. 3A is 1 plus D 1/2 plus C 3.5. So C is minus 3.5. No, 3.5. 3.5. 3 times 2, 6 minus 7/2. Okay, thank you very much, students. Because of you, okay, this is a problem that I designed by myself. So to help you to do the exam. So that's why I got stumped a little bit. But you know, you must know, should be able to do this. The idea is you are given a few signals here. And then you must know what combination you need to add to get the required output, This is the required output here. This is the required output. But you're not going to get any, what you're going to get is just the A, B, and C. And then plug into this equation. Once you found out your A, B, and C, okay, this is not really Y. This is the input. Sorry about this. Okay, this is, sorry, I made a mistake. This is not really the output. Sorry about this. What are the inputs? Combination of input to realize YN. Okay, so once you find this, so this is the combination of input. AX1 we just can call this A, B, C, D. A is 1, right? So this is like, this was like A. C is minus 7/2 X3N. And then D is 1/2. So this is the combination of the input required. Input required. The problem that you're going to get is much. A system is time invariant if its input-output characteristics does not change with time. For example, you have an input, and the input is going through a system. This is maybe T. T stands for system. Never mind. This is a system. You're going through a system and then you get an output yn. If this input is delayed by some k unit, n minus k, then the output also must reflect the same delay by k unit. So for all k's, all k values, input if output yd n is equals to yn minus k. We know from the last time what these two things are, right? We know that this is output, input, delayed output. This is output, delayed output. Earlier on, we have already gone through this. So if this is equal, then this is time invariant. So these two are equal. Then it's time invariant. Then it's time invariant. Invariant for all possible values of k. For all possible values of k. Let's say if y dt is not equals to y n minus k, that means output, input, delayed output. Input delayed output is not equals to output delayed output. In this case, it's not time invariant, not even not time invariant. For even one value of k. Not time invariant. Okay, what this is telling is, if this is the case, it's not time invariant for even one value of k. That is not time invariant. Even if this rule is, even for one value of k, this is violated, then it's not time invariant. Even for one value of k, y dt is not equals to yn minus k, then the system becomes time invariant. It must hold for all values of all possible values of k. Then only you call this time invariant. Okay, now we do an example. This is a very important example again. You have to understand this. Very important that you guys understand these things. Example. Example yn is equals to xn input delay by k units. You try to input. Now let's see what happens when the input delayed by k units. Input delayed by k units, then the output, we call this output ydn, remember? The output corresponds to the input delayed by k is called ydn. Now input delayed by k, n minus k minus x, n minus k minus 1. Okay, that is input delayed output. Input delayed output. Input delayed output. Now let's look at the output delayed output. Output delayed by k units. Yn minus k so all you need to do, you are replacing the output with n minus k. Replacing the n with n minus k, then you have to replace all the n's with n minus k, minus x, n minus k minus 1. So now you look at this. Look at this and you compare these two. One is input delayed output, one is output delayed output. It's output delayed output. Output. Are they the same? Is yd n same as y n minus k? Are they the same? Same, correct?
Yes,
Same.
it is.
Yes, same.
Same. Therefore, it is time invariant. It is time invariant. You just look at the equation, you're just comparing the equation. And then let's see how you can see this visually with a simple graphical demo. Graphically, to see this graphically, let's k equals to 1. The delay by k units. Now you let k equals to 1 unit in time. Okay, now let's go back to the equation. Ydn was x. Now you replace the k with 1. I'm replacing the k with 1. So when you replace the k with 1 in this equation, replacing the k with 1 in this equation, So it becomes n minus 1 and n minus 2. Xn minus 1 minus xn minus 2. Okay. Okay, let's just sketch this. Let's do this in red color or blue color or whatever. Okay, let's do that. Now I'm doing the same thing again. Y n minus 1, same thing, but now we replace the k with 1. Now I'm replacing this k, letting this k equals to 1. It's also going to give you the same thing, x n minus 1 equal to x n minus 2. So if we go ahead and sketch these things, let's sketch the blue one first. Since I'm already in blue, y n minus 1. So x n minus 1, where's n minus 1 located? Right here. It's 1 minus x minus. So this is the other one is located at 2 because it's minus. Okay, that's x y n minus 1. Now let's plot y d n. Also same, you're going to get one spike here, and then you're going to get another spike here. And you see they are equal, right? And you can see they are equal. There's another way to look at it. You should be able to look at this equation wise and also graphical wise. But then you can be able to tell, instead of giving an equation, if you're given signal plots, you should be able to tell, is there any time invariant? Now you can see there's no difference between this and 2. Any questions so far?
No, sir.
No, sir.
Therefore, I can use, okay, thank you. Yd n is equals to yd n minus, sorry, y n minus 1. So therefore, it's time invariant. Let's look at another example. Another example. Let's say you have yn and xn. Now you want to know whether it's time invariant or not. So let's find out what's YD. And is simply replacing the input, it's just delaying the input. What is the input here? The input is X, whatever that's inside here, right or not? The input is X, N. So now if I'm going to delay this by 1, delay by 1 unit, okay, that's output, input delayed output. Delay by 1 unit. Okay, that's going to be, if you sketch this, it's going to be like this. It's happening when n equals to 1. So it's right there. The amplitude is n. Right or not? If amplitude is n equals to 1 here. Right or not? So therefore, n is must be 1 here also, right? You can just simply put 1 here then. You guys not sure, then I can just put you so you know n is 1. N is 1. Now we go ahead and delay output by 1 unit. Delay output by 1 unit, therefore you just go to the output and replace the n with n minus 1. When you replace the n with n minus 1, then everywhere becomes n minus 1. Oops. Changing and let's go ahead and plot this. Okay, the thing is, it's happening same as before. You're going to have a spike at, you're going to have the signal when n equals to 1. Okay, that's fine. Same as before. But what about the amplitude? Amplitude is n minus 1. N minus 1. Because n is 1, so 1 minus 1 is going to 0, right? So that's, you see the input delayed output and output delayed output, not the same. On one of them giving you n equals to 1, it's giving you a 1. On the other one, at n equals to 1, it's giving you a 0. Any question? Is this time invariant? Is this time invariant? Is this time invariant? Hello? Can somebody reply, please?
No, sir.
No, sir, no.
Not
No,
equal,
sir.
sir.
No, sir.
No.
Okay, thank you. system response. Okay, this is nothing new. You guys go to the mathematics 2A. This is something that you have learned before. Upload in signal and systems folder. So you already know what is Fourier transform, everything. So you already know what's Fourier transform and everything, right? And LTI. System with the frequency response. This frequency response H omega, function of omega is 1 over 1 plus j omega plus 2 over 2 plus j omega. 1 over 2 plus j omega. Find, if you still remember this system, any of the system, and with the system usually you have HT in time domain, output. HT is called the impulse response. YT is the system response. YT is the output. XT is the input. In time domain, in frequency domain is called X omega. Frequency domain is capital H omega. In frequency domain is capital Y, function of omega. So you guys know all this. So you want to find the impulse response HT. Find the impulse response HT. Number 2, find the impulse response. Okay, 1, 2. System response. System response YT. To the input XT E minus T. Okay, given HT, to find HT, let's do number 1. To find HT, you just take the inverse transform of H omega. So inverse Fourier transform of H omega. Okay, what is the inverse Fourier transform in
Yes,
Laplace is e to the AT? Now Laplace, what's the difference between Laplace and Fourier transform? In Fourier Laplace, S equals to, in Laplace, S is equals to a real and imaginary part. But in Fourier transform, this is Laplace, by the way. In Fourier, somebody's having the mic on, please mute it. In Fourier transform, S is j omega. Same thing. So instead of S, you put j omega. So what is 1 over j omega plus a is equal to what? Fourier transform, inverse Fourier transform. This is this arrow here means arrow here means you can go back and forth from time domain to frequency domain, from frequency domain to time domain. So this is called the Fourier transform pair or Laplace transform pair. So I'm asking you now, what is the Fourier transform pair for 1 over j omega plus a?
e to the power of e to the power of minus at.
Oh, okay, good. So is there any difference between Laplace and Fourier in this answer? Same answer, right?
No, same answer.
Yes,
Sir.
sir.
I already mentioned this in mathematics 2A, but you guys were, a lot of you were taking okay, it's not going to be like mathematics 2A. Yeah, it's going to be really understanding if you know how to do or you don't know how to do. So in the exam, if you put j omega t, then I'm not going to tolerate these things. And so it's for you to go out there and fix it. Okay, now 1 over 1 plus j omega, or same as j omega plus 1. So what is the form of 1 over 2 plus j omega?
Is e
E
power
to the
of
power of
negative 2t.
2t.
Okay, thanks. Then don't forget, you have to put back this ut to show that your solution is t is greater than 0. So this solution will converge only when t is greater than 0. So yt. Now I'm asking you, system response means, what is yt? When the input is given e to the minus t. The input in this case is given xt is e to the minus t ut. So what is the output? Okay, let's do this. To get system output, first analyze first analyze the frequency domain. So the frequency domain, you know, right, the output here is equals to, last time you know, the output is xt convolution with ht. But in the frequency domain, y omega is equals to x omega multiplied by h omega. Convolution in time domain is multiplication in frequency domain. So we want to analyze things in frequency domain because doing convolution is very difficult. We can do also in convolution in time domain. Plus x omega. H omega you already know. 1 plus j omega 1 plus 1 over 2 plus j omega multiplied by, one is the Fourier transform of multiplied by the Fourier transform of xt. That's the input. Okay. Fourier transform so we already know h omega, but we in frequency domain, but do we know x omega in frequency domain, which is a Fourier transform of xt. The Fourier transform of xt is Fourier transform of et. So what's that's equal to?
One over one plus j omega.
1 over 1 plus j omega. Okay, good. 1 over 1 plus j omega. So next, what you need to do, you have to multiply them one by one. You have to multiply through, and then you will get 1 over 1 plus j omega squared plus 1 over 2 plus j omega 1 plus j omega. So this is the x omega. Let me put this. After doing partial fraction, you don't need partial fraction for this, but you have to do partial fraction. After doing partial fraction, all we have done this before. So why should I do this again and waste my time? This is not a class in algebra. This is a class in signals and systems. So you guys should know how to do this. After doing the partial fraction, this remains as the same, j omega squared plus 1 over 1 plus j omega plus 1 over 2 plus j omega. After doing the partial fraction, you get this. don't put ut, you lose points. ht. xt is given as t e to the minus 2t ut ht ut. Okay, convolution in time domain, we told you earlier, right? Convolution in time domain is equivalent to multiplication in frequency domain. So therefore, to solve this problem, I have to do Fourier transform to convert everything to frequency domain. Convert to frequency domain. X omega is 1 over 2 plus j omega squared. H omega is 1 over 4 plus j omega squared. Okay, you take the Fourier transform, maybe one of them doesn't have a square. Only the ones with t as a square. So this doesn't have a square, right? The square come from the t e to the minus 2t. The other one is just e to the minus 4t. You guys go later on, you can, during Labor Day, you can sit down and labor and read by yourself. Y omega is x omega, h omega is 1 over 2 plus j omega squared multiplied by 1 over 4 plus j omega. Partial fraction, you're going to get 1 over 4 j omega plus 4 e to the minus 2t Okay, that's it. Let's move on to the next one. So that is the answer. So you have system. This is a differential equation. Plus 6 dy dt plus 8 dy dt is equals to 2xt. Let ht be the impulse response. ht be the impulse. Find h omega. H as a function of omega. In order to do that, you have to take the Fourier transform of the differential equation. Omega squared y omega plus 6 taking the Fourier transform of the entire differential equations, j omega y as a function of omega plus 8 y as a function of omega, and that's going to be equal to 2 x as a function of omega. Now we just factor out the y omega. You will get y, factor out the y omega, you get j omega squared plus 6j omega plus 8 equals to 2 x omega. So h omega is the frequency response. Which is equals to the output divided by the input. And that's going to be equals to 2 over j omega squared plus 6j omega plus what, 8, right? Okay, 8. Okay, that's going to be equals to 2 over j omega squared. J squared is -1, so it's going to be minus omega squared plus 6j omega plus 8. Put h omega in standard form so that you can do the inverse Fourier transform. How do you put that in standard form? We need to factorize. Factorize the denominator. See, in order to factorize it, it's a good idea if you can, because with the negative sign, at a negative sign with minus omega squared is going to make it difficult to factorize. So usually the best practice is to factorize the negative sign. And then you factorize it. Factorize, I don't know how you guys factorize, but this is how usually I factorize. Minus j4, j2. Omega times omega gives you omega squared. Check. Minus, okay, now you multiply things this way. This is going to give you minus 4j omega. You multiply this way. You multiply from left to right. You get minus 2j omega. If you add them together, you will get minus 6j omega. Check. Okay, if you multiply these two guys here, you will get j squared 8, which is going to be, j squared is minus 8, right? Check. Okay, therefore your factor is going to be this. Omega minus j2 multiplied by omega minus j4. So now we can rewrite these things. So factor is, you found that j2 okay, the minus sign still remain there. Okay, so it's going to be it's 2 here. After doing the partial fraction, it's just the inverse Fourier transform of h omega. That's going to give you e to the minus 2t minus e to the minus 4t. Okay, get out of here for the Labor Day. Okay, see you guys the next time. If you have any question, if